See the elements list. Elements list. Nitrogen. What is the symbol of nitrogen?
N.
Nitrogen symbol N. I am writing atomic number also. This is atomic number. Nitrogen. Phosphorus. Phosphorus atomic number is 15. Arsenic. Symbol for arsenic 30. Antimony. (51). Bismuth. (83). And newly discovered element Moscovium. EMC 115. Atomic number is 115. Okay, Adiba, can you able to see? Adiba, we should know the atomic numbers also and electronic configurations also. Okay, but everything in the inorganic. Right. Let us write electronic configurations. Nitrogen electronic configuration 1s2, 2s2, 1s2, 2s2, 2p3. See, in place of 1s2, can I write helium? Helium configuration is 1s2 only, na? So I can write like this: helium. Helium 2s2, 2p3, because helium is 1s2, so we can write like this: helium 2s2, 2p3. Okay, next phosphorus. Phosphorus, helium after which net gas will come? Neon. Neon 3s2, 3p3. Increase energy level 2, 2, 3, 3. Outer configuration is ns2 np3, ns2 np3, so 2, 3, 4 like that. Next, neon after argon. But look at this, here atomic number increased, right? So we have to add d orbitals. Argon 3d10, 4s2, 4p3. ns2 np3 is outer electronic configuration, that is common for every element. Okay, argon 3d10, 4s2, 4p3. Helium, neon, argon. Okay, in the sequence. Argon after krypton. Krypton 4d10, 4d10, 5s2, 5p3, 5s2, 5p3. Next, xenon. And remember, in last two elements, f orbitals will come. F orbitals will come. Okay. 4f14, 5d10, 6s2, 6p3, 4f14, 5d10, 6s2, 6p3. Moscovium, radon, 5f14, 6d10, 7s2, 7p3. Last element electronic configuration is very, very important. Moscovium configuration is very, very important. See how to remember. F is, what is f orbital capacity, Adiba? 14. D orbital capacity? 10. So fill 14, 10 over. Last configuration means outer configuration. ns2, np3. 7s2, 7p3. Okay, learn the configuration of Moscovium. Important, Moscovium. And you tell me what is the IUPAC name of Moscovium according to periodic table, first year periodic table. Unpentium, unpentium. You can add that also. Unpentium. One means Un 5 means pentium. Unpentium. Another important point about moscovium, it is a synthetic element, man-made. Synthetic means man-made element, man-made, not naturally occurring. Synthetic element means man-made. And radioactive. Additional information, radioactive. But chemistry is not known because this is recently discovered. Chemistry not known means we do not discuss its properties or compounds formed by it because it is newly discovered. Okay, right. Will know. Right. Okay, next. Next heading, metallic nature and physical state. Metallic nature and physical state. Metallic nature and physical state. According to NCERT, we go. Okay, inorganic is mostly NCERT based on our discussion. Our questions also will come according to NCERT only in the NEET. Okay, right. Nitrogen and phosphorus, arsenic, antimony, bismuth. Nitrogen and phosphorus, these are non-metals. Nitrogen, phosphorus, non-metals. Arsenic and antimony, metalloids. Bismuth is a metal. Okay. Metalloids are important. Which of the following is a metalloid? Arsenic and antimony. Tell me what are the atomic numbers of metalloids in 5th A group? Like this also you will get arsenic 33 and 51. This is metallic nature. Down the group metallic nature increases or not? So as we move down the group metallic nature increases. So write that also. Metallic nature increases. Metallic nature increases down the group. Increases down. Next, physical state. Shall we go to next page, Adiba? Nitrogen exists as a gas. Phosphorus exists as waxy solid. Arsenic, antimony, bismuth, crystalline solids, exist as crystalline solids. Increases. What I said? Increases only. Okay. I wrote correct only, but during explanation I said decrease. Correct only I said na. Adiva. Increases. Increases. Right. Physical state is over. Right. Next. Abundance. Abundance. Okay, then I'll go slowly only. Actually, I habituated for this crash course and second years. That's why I'm going fast. Okay, I'll go slowly, no issue. Abundance. Nitrogen is 78% abundant by volume in air. 78% abundant. 75% by mass. By mass in air. Okay. Phosphorus. Phosphorus occur in the form of minerals in the nature, in the earth crust. Okay. Nitrogen is abundant, mostly nitrogen is abundant in the air only. Okay. And phosphorus occur in the form of minerals in the earth crust. Here very important point is to learn the minerals or ores of phosphorus. You have to remember the minerals or ores of phosphorus. At the same time, nitrogen also exists, okay, in the earth crust in the form of different salts. Okay, we should learn that. So what I am going to say, keep star mark for this. Important. Phosphorus ores or minerals are important. See, ore or mineral. What is the meaning of ore or mineral? It is a chemical compound present in the earth crust from which we extract particular element. For example, you need iron. We use iron in different areas, right? In day-to-day life. Clear? So where will get iron? From the earth crust. From hematite. Hematite is the chemical substance. From hematite we will extract the iron. So ore or mineral is the chemical substance from which we extract particular element. Okay? Ores of phosphorus are minerals. First one. Fluoropatite. You have to by heart and practice this. Fluoropatite. Ca3PO4 taken twice. CaF2. This is calcium phosphate. This is calcium fluoride. Calcium phosphate. This is calcium phosphate. Very important question. The elements present in the fluoropatite. Can you say the elements present in the fluoropatite? What are the elements present in the fluoropatite? Calcium, phosphorus, fluoride, oxygen. Okay. In the weekend exams, they are giving the questions like this. And fluoropatite is the ore of phosphorus. Means in the nature, phosphorus exists as a fluoropatite. Okay. In order to get the phosphorus, what we have to do? We have to take the ore, fluoropatite, and we have to do some chemical operations. Okay, to get a pure phosphorus. Okay, fluoropatite. Second one, chloropatite. Chloropatite. Same formula. Ca3PO4 taken twice. CaCl2. Dot CaCl2. Hydroxyapatite. Fluoroapatite and hydroxyapatite. Which of the following is the ore of phosphorus? Like that, questions will get. Three Ca3PO4. You multiply this 3. You tell me, multiply and tell me. Multiply this 3 with this Ca. Tell me, Ca. 3 into 3.
9.
Ca9. PO4 taken 6. Okay. In NCERT given like this. But in the questions, this form will come. So write NCERT format also. Okay. If you open NCERT, you can see this like this. Ca9 PO4 taken 6 CaX2. What is X here? Chlorine. Okay, general formula. X is halogen. We know already. Okay, this is general format according to NCERT. But if I write like that, you cannot identify the elements present in the ore. That's why I given complete formula. Okay. But write that also. Next. Shall we go to next page, Adiba? Nitrogen ores. Nitrogen ores are minerals. Chile saltpeter. Chile saltpeter. NaNO3. Chile saltpeter. It is a salt, sodium nitrate salt. Chile saltpeter. Indian saltpeter. Indian saltpeter. KNO3. Chile saltpeter, Indian saltpeter. And nitrogen also exists in the form of proteins in animals and plants. Okay, in our body proteins are present now. In protein, nitrogen atom is present. Nitrogen also exists in animals, plants. In the form of proteins. Means proteins contains different elements: carbon, nitrogen, oxygen. Okay. NCERT, according to NCERT. Okay, right. Next, see, nitrogen, phosphorus is our arsenic, antimony, bismuth. Remaining, right, these exist in the form of sulfides. Just the statement is enough. Remaining elements, arsenic, antimony and bismuth, exist as sulfides. Write one simple statements. Arsenic sulfide, antimony sulfide, bismuth sulfide, like that. In the nature, how they exist as sulfides. Next. Atomic radius. Atomic radius. Atomic radius, electronegativity, ionization energy. All these are based on the periodic table only. Okay, we use periodic table concept and we'll discuss. You know, according to periodic table, what happens to the radius when we move down the group, Adiba?
Increases.
Atomic radius increases. Why atomic radius increases? Why atomic radius increases? Because every time new shell will be added. New shell will be added. So, right. As we move down the group, as we move down, atomic radius as well as covalent radius increases. This is based on the periodic table only, because every time member to member new shell will be added. We explained that, okay, in periodic table chapter, how variation takes place in the radius. Okay. So which is having greater size? Bismuth. Bismuth size is larger compared to remain. We'll see. Just a second. I'll keep in the silent mode. Once look at this. Increase is taking place, no doubt. Increase is taking place, no doubt. See, nitrogen to phosphorus, considerable increase. Considerable increase means, look at this. For example, this is the size of, just a random structure I am taking. This is the size of nitrogen, size of phosphorus. Considerable means we can identify the difference, right? Small size, large size, considerable increase. And look at this. Here also increase is taking place, but you tell me, this size to this size, is there any considerable or small increase? Small increase, right? Correct only, no? So nitrogen to phosphorus, considerable increase in the size takes place, and arsenic onwards there is no considerable increase. Why? Because in arsenic onwards, once you can see in the configurations, we wrote d orbitals and f orbitals are not. Adiba, yes or no? We wrote d orbitals are not. Arsenic onwards d orbitals are entering or not. Clear? So what happens when d orbitals are present? D orbitals and f orbitals are present. Their screening capacity is less. Their screening capacity or shielding capacity is lesser. So outermost electron is attracted by the nucleus. Okay, so increase in the size is less. Increase only, general statement only, down the group size increases. But according to NCERT textbook, this statement is given. Nitrogen to phosphorus, considerable increase in the radius takes place. But arsenic onwards, less considerable increase or small increase in the radius takes place. But overall increase only. But if we mention that point, that is good. Okay, due to poor shielding of d and f orbitals reason also. So under note I am giving that point. Up to phosphorus, considerable increase takes place. Arsenic to bismuth, small increase in radius takes place. Due to presence of d and f orbitals in the heavier elements. Heavier element means last elements. Heavier means whose atomic number is more. Okay, small increase in the radius takes place due to presence of d and f orbitals. Okay, that is a big story again. Screening effect, shielding effect. We don't go to that concept. Just we use the applications of periodic table only. Okay, because questions won't come based on the core part of the periodic table. Okay, just we mention a reason is this one enough. All right. Shall we go to next page, Adiba? Ionic radius. Ionic radius also same, increases down. Atomic radius, ionic radius, covalent radius, same concept. I'm taking last three elements in ionic form: nitrogen, phosphorus, arsenic, antimony, and bismuth. Last three elements I am taking in the ionic form: arsenic, antimony, and bismuth. You tell me what is the symbol, less than or greater than? Increases down now. So which is having larger size? Say the element: arsenic ion or bismuth ion. Which is having larger size? Bismuth. Down the group, ionic radius increases, similar to atomic radius and covalent radius. Put in a box. Important. Bismuth size is larger. Large size. Atomic radius. Next, keep heading: ionization energy. Ionization energy. Ionization energy. Once I'll revise the definition of ionization energy. What is ionization energy? What is ionization energy, Bhakti?
The minimum energy required by an neutral gaseous atom to lose one electron from the outermost orbit to form a positive ion is called ionization.
The amount of energy required to remove an electron from the isolated neutral gaseous atom is called as ionization energy. What happens to ionization energy while we move down the group?
Decreases.
Nitrogen, phosphorus, arsenic, antimony, bismuth. See, moving down the group, size increases, ionization energy decreases. Bismuth is having more ionization energy, so I am writing ionization energy order. Nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay, Adiba, next page. Ionization energy. Next, keep getting electronegativity. Electronegativity. Electronegativity definition is easy. Electronegativity means it is the tendency to withdraw bonded electrons towards itself by an atom is called electronegativity. Which is more electronegative atom in the periodic table? Just let us revise electronegativity few points. Which is more electronegative in the periodic table? Fluorine. Phone call code. Fluorine is the more electronegative element after the oxygen, next nitrogen. This is general information. Okay, right. Here electronegativity decreases down the group according to periodic table. As we move down the group, electronegativity decreases, but in second year inorganic, especially groups P black, we can see exceptional cases. Okay, there is no correct order. Okay, so we have to remember that. By seeing this, you tell me electronegativity order. nitrogen, phosphorus, arsenic, antimony, and bismuth. You tell me by saying this, which is having more electronegativity? Which is having more electronegativity? Nitrogen. Nitrogen after
Phosphorus, arsenic.
phosphorus after arsenic after antimony, and antimony is equal to bismuth according to NCERT data. In NCERT, they will give the table according to the table I given. Antimony and bismuth are having same electronegativity. So in the exceptional, mostly reasons will be discussed, but in some exceptional cases we do not discuss any reasons. You have to remember directly inorganic is like that only. Okay, we should not waste the time unnecessarily on exceptional cases. Okay, if any proper reason is there, then I'll explain. Okay, but this is electronegativity. Now coming to the another concept, melting point, most important. Melting point. Melting point. Melting point order is not a perfect order. Okay, there is no criteria, so we have to remember codes here. Codes I'll give you. For melting point, the code is V, alphabet V, V letter. You know V letter, alphabet. This is melting point on the y-axis. This is atomic number Z. Once look at this, how I am writing that V in the inverted form. V in the inverted form. Once look at this. Actually, we write alphabet V with two straight lines, right? Yes or no? One line like this. Nitrogen, phosphorus, arsenic. Okay, another line. Be careful. See how I am writing another line. Short line, and dot should not come down the phosphorus. Very important. By mistake, if you draw little bit lengthy, then you will get wrong order. Okay, see, once observe, these two dots are above phosphorus only. So code for melting point, these codes will help you a lot. Okay, if you know any exceptional case reason, then you will forget that. Instead of that, codes are very important. So fifth A group elements melting point code is V shape, inverted V. Not normal V, this is inverted V. Inverted V. Now you tell me which is having more melting point. Once this line represent melting point, axis represent melting point. Which is having more melting point? Arsenic. Arsenic after? Arsenic, antimony, and bismuth. Okay. Now right order. You will get directly question only. Okay. You don't do the research. Okay. Unnecessarily. If the concept is important, then I only will explain. Okay. So write melting point order. Order of melting point.
Arsenic, antimony, bismuth, phosphorus.
Yes. Arsenic is greater than antimony. Antimony is greater than bismuth. Bismuth is greater than phosphorus. Phosphorus is greater than nitrogen. Arsenic is having highest melting point in the fifth group. These melting points, boiling points depends upon their crystal structures. Okay, every time we can see exceptional in every group. Okay, the reasons are due to their different crystal structures. Like that they will give in the textbooks, but we won't satisfy with that. We have to continue like this, like that only by using the codes. Okay. Next melting point is our boiling point. Next boiling point. Shall we go to next page, Adiba? boiling point increases with exception, with one exception. Okay, boiling point increases down with one exception according to NCERT. I am giving, okay, by using NCERT table only. Increases down means, see, nitrogen is less than arsenic after which will come nitrogen, phosphorus, arsenic, antimony, bismuth, but swap last two. I said now one exception, bismuth, antimony. Swapping in the last two elements, you just write swap last two. If you write regular order, actually according to my statement, nitrogen is less than phosphorus, arsenic, antimony, bismuth will come last, but exception, swap last two. Okay, melting point is over, boiling point is over. Next, keep heading, oxidation states. Common oxidation states. Common oxidation state. -3 plus 3 plus 5. -3 plus 3 plus 5. Okay. Ability to show -3 oxidation state decreases down. Ability to show -3 oxidation state decreases means nitrogen shows -3 oxidation state more predominantly compared to remaining elements, because as we move down the group, metallic nature increases. So metals form positive oxidation states only, not negative. So remember this point, ability to show -3 oxidation state decreases. Common oxidation states are -3, +3 and +5, and this is one important topic in 5th A group, oxidation states. Okay, next, nitrogen exhibits, or nitrogen shows variable oxidation states. Nitrogen shows variable oxidation states. Let us see in which compounds nitrogen shows variable oxidation states. You know how to calculate oxidation states in stoichiometry. Recently you did balancing redox reactions. Okay, nitrogen oxidation state in N2, in NH3, in N3H, in NO2, and in N2O5, HNO3. Can you calculate nitrogen oxidation state here? In N2, what is the oxidation state? Adiba. Nitrogen oxidation state. 0. In homoatomic molecules means molecule made up of same kind of atoms, N2, S8, P4. Are you seeing any other element? No. Made up of same kind of atom only. No. Their oxidation state is 0. Here oxidation state is 0. In NH3, normal method. So we consider, -3. Nitrogen is the unknown element. We take its oxidation state as X. Hydrogen is +1. So if we calculate, we will get a -3. In hydrozoic acid, note down its name. Its name is important. Hydrozoic acid, N3H. Hydrozoic acid. In N3H, what is the oxidation state? Can you tell me, Bhakti? Go with the normal method only. This is X. Unknown is X. No? Look at this. No, not like that. See, this is X. Unknown is X. Hydrogen is +1. Okay. 3 into x, 3x plus 1 is equal to 0. Then x is equal to send minus 1, plus 1 that side minus 1. So minus 1 by 3 fractional oxidation state. So minus 1 by 3. In NO2, plus 4. Oxygen common oxidation state is minus 2. This is normal method of finding oxidation only. This is x, oxygen is minus 2. X 2 into minus 2 minus 4 is equal to 0, then x is equal to plus 4. So here it is plus 4. Here minus 10 plus 5 plus 5 plus 5. In HNO3 plus 5. Okay, normal method only. Okay. The important point is nitrogen shows variable oxidation states. It is important point. HNO3, yeah, it is not visible. Just a second. Okay. Now my question is, in which of the following nitrogen exhibits lowest oxidation state? Answer.
And
Nitrogen exhibits lowest oxidation state. Lowest means lower value.
and
NH3, 0 and minus 3, which is lower value.
okay.
Like that. NH3, minus 3 is the lowest value. Okay. Right. Can you tell me nitrogen oxidation state here in NH4NO3? In NH4NO3, what is nitrogen oxidation state? Split this NH4 positive, NO3 negative. Now calculate. NH4 NO3 dissociate into NH4 positive and NO3 negative. Here nitrogen shows
4
minus 3. General calculation only. How? Nitrogen is X, unknown element.
4 plus
4 into 1 and this side plus 1. So X is equal to minus 3. Here n is equal to directly plus 5. Then additional information only, leave it. So based on the redox reactions, okay? You can leave this, right? Coming to very important, keep adding stability of oxidation states. Most important and question coming area. It will take some time, okay?